Hey guys, it's Bruno, the IB math teacher. So we've just crossed the 50% mark. We went through the first 5 weeks. Now we're going to start week number 6 of the Ace Your IB math exams in 10 weeks. First of all, congrats. It's challenging, it is hard, the questions are hard, but they do prepare you in a very good way, in a very realistic way for the upcoming IB math exams with all sorts of questions, all styles of questions, with all topics, paper 1, paper 2, number and algebra, functions, you name it, everything is there. And we're going to continue that. We're going to continue for the next 5 weeks. So this is week number 6. If you've missed any of those, you can find the links for these videos and the PDFs in the description of this video right here. Everything is for free, and do share away. Share it with your colleagues, with your friends, so you guys can study together. And yeah, without further ado, let's get to it. Week number 6 of the Ace Your IB Math Exams in 10 Weeks challenge. Exercise number 1 is one that involves arithmetic sequences with trig. It's an interesting mix. Let's get to it. The lengths of the 3 sides of a triangle form an arithmetic sequence with common difference d and middle term a, which were not given initially. We need to prove that the cosine of the largest angle, and we know that the largest angle opposes the largest side, is given by cos theta equals a minus 4d over 2a minus d. Now, a sketch goes a long way over here. I drew this triangle very asymmetric, so we'll have a largest angle opposing a largest side. Now, if the common difference is d and the middle term is a, and we know that to go from one term in an arithmetic sequence to the next one, we have to add d, or to go backwards, we subtract d, the difference. That means that the 3 terms of this arithmetic sequence, they are a minus d, a, and a plus d, which means that this guy over here, which opposes our angle theta, is a plus d. And we can select in any order the other 2 sides, a minus d and a. Now we're talking cosine, and we're also mentioning the 3 sides and an opposite angle, so this looks like a cosine rule type of problem, and that's exactly what we're going to apply right now. So we have a plus d squared equals a minus d squared plus a squared minus 2a minus d cosine of theta. We can find, of course, this formula in the formula booklet. So we have a squared plus 2ad plus d squared equal to a squared minus 2ad plus d squared plus a squared minus 2a minus d cosine of theta. We're not going to FOIL, we're not going to distribute the 2a. And we can simplify these guys. We have over here a 4ad if we move the negative 2ad to the left-hand side. And we can also move this to the left-hand side as well. So we have 4ad minus a squared equal to negative 2a minus d cosine of theta. We can also factor out an a over here, so we can cancel 1a with this one over here. Therefore, we have a minus d cosine of theta equal to 4d minus a over negative 2, which, by the way, is the same as a minus 4d divided by 2. So we have a minus d cosine of theta equal to a minus 4d divided by 2, as I mentioned. And we can divide everything by a minus d, which gives us 2 times a minus d in the denominator, which is exactly what we needed to prove. Now, let's say that the sum of the 3 sides is 21, which means that a minus d plus a plus d is equal to 21. This is already enough for us to calculate the middle term, due to the fact that in this equation we're going to cancel out the d's, and we're going to have 3a equal to 21, which means that a is equal to 7. Now for question 2i, if we consider the difference to be 0, that means that this is equal to 7, this is equal to 7, and this is 7 as well. And what does that mean? Well, it means that we have an equilateral triangle, so all 3 sides are the same, all 3 angles are the same as well. But if we consider, and now this is exercise 3i, the difference to be 3, that means that this side is 7, this one is 10, and this one is 4. And to find the area of this triangle, if we know this angle, we could do half AB sine of c, sine of theta. Now we need to find cosine of theta first in order to find sine of theta. And that's an easy process because we already have a formula for cosine of theta. We deduced this formula for this specific case. we know that cosine of theta is a minus 4 times the difference over 2 times a minus the difference, which gives us negative 5 over 8. Now we can see cosine of theta is negative. We can see that theta is an obtuse angle. So theta is greater than 90 degrees and less than 180, or pi over 2 and pi. Now, knowing that cosine of theta is negative 5 over 8, this allows us to use the trig identity sine squared plus cosine squared equals 1 in order to find sine of theta to then calculate the area. So we have sine squared plus negative 5 over 8 squared equals 1. So sine squared of theta is 1 minus 25 over 64, which means 39 over 64. Therefore, sine theta is, by the way, this is squared. Sine theta is root of 39 over 8. Should it be positive? Yes, it's an obtuse angle from 90 to 180. Sine of theta should be positive. It is positive. So let's take this and move it up. We have this area as half 1 over 2 times this side, which is 4, times this other side, which is 7, times the sine of theta, which is root 39 over 8. So this is 7 root 39 over 4. Now do notice that in this exercise, the GDC is not allowed. This is a paper 1 style question. So let's move to exercise 2 now. So in exercise number 2, we have a rational function. One of the things that makes this exercise a little bit more difficult is the fact that we do not know what k is. We only have its range. It's somewhere in between 2 and 3. And that makes for a slightly more challenging problem, especially when you're graphing this function. But let's take it step by step. Question A. Given that f of x is 2 minus x minus k over x plus k, show that this f of x can also be written like this. And it's much easier to go from here to here, meaning proving that 2 over x plus k minus 1, which by the way can be rewritten using a common denominator, we need to show that we're going to get exactly here. Now, we have in the numerator 2 minus, and given that the denominator here is 1, if we multiply both the numerator and denominator by x plus k, we get 2 minus x plus k in the numerator, which means exactly what we had before. So 2 minus x minus k over x plus k. Now the word hence shows that we need to use the answer that we got from question A in question B, which means in this case, it should give you a slight hint, meaning that it's much easier to see the transformations if you think about f of x like this as 2 over x plus k minus 1. Now, what's the parent function here? Well, it's g of x, which is 1 over x. And we have 3 transformations. Number 1, a horizontal shift k units to the left, which produces 1 over x plus k. Transformation number 2, a vertical stretch by a scale factor of 2, which gives us the following. And transformation number 3, a vertical shift 1 unit down. Now let's list all these transformations right here. And do remember that the transformations which involve x, they come before the ones that involve y. That's why the vertical shift 1 unit down was the last one. So horizontal shift k units to the left, vertical stretch by a scale factor of 2, and then lastly vertical shift 1 unit down. And now we proceed to the sketch. Now let's base our analysis in the transformations that we have starting from 1 over x, which is the parent function. If the goal was to graph 1 over x, you would have a vertical asymptote, which is x equals 0, and also a horizontal one, y equals 0. Now this is, of course, if the function was 1 over x. Now let's take into account the transformations. We have a horizontal shift k units to the left, which means that our new vertical asymptote will be x equals negative k. Then we have a vertical stretch by a scale factor of 2. And given that I didn't place any scale in this graph, I can just copy the same one. It's important to notice that the vertical asymptote will not change, which is the same case for the horizontal one right now. But on the next step, which is a vertical shift 1 unit down, now in this case, we will have a change in the horizontal asymptote, which will be y equals negative 1. So we have the following curves. Now we can also find the intersection with the x-axis, which is when y equals 0. So we have 2 over x plus k minus 1 equals 0. 2 over x plus k equals 1. If you cross multiply, you get 2 equals x plus k, which means that x is 2 minus k. So the coordinates of A are 2 minus k, comma 0. And for point B, which is the y-intercept, we can evaluate f of 0. So for x equals 0, we have 2 over 0 plus k minus 1, which is 2 over k minus 1. So we have 0 comma 2 over k minus 1. Now we can jump to question D, which is to find the domain and the range of this function. The domain should involve all x values with the exception of the vertical asymptote, which means all real numbers except for negative k. And for the range, excluding the horizontal asymptote, we have all real numbers except for negative 1. And now we can jump to question E, which is to find the composite function f of x. And with that, stating what is the equation of the horizontal asymptote. Now, don't do what I'm doing right now. So you want to be very organized when you're writing your answers in the IB exam. I'm just drawing multiple graphs and multiple diagrams to explain this with more detail, but you want to answer everything sequentially. Now, what is f of x? Given that this is our f of x, we're going to plug in f of x in every x that shows up in f of x again, which is, by the way, only in one place, which is right here. So we have 2 over f of x plus k minus 1, and instead of this green box, obviously, we're going to write f of x again. And to simplify this, we can use a common denominator in the denominator, meaning x plus k in the denominator, which will give us 2 plus this negative 1 plus k times x plus k, all this minus 1. And this gives us 2 over 2 minus x minus k plus kx plus k squared, all that over x plus k. And we can multiply the 2 in the numerator by the reciprocal of this fraction, which gives us this. And simplifying it a bit more, we need now to combine this fraction with the negative 1, which means writing everything over the same denominator, which means that we're going to have 2x plus 2k minus 1 times everything that's in the denominator here. So minus 2 plus x, we need to flip every sign, plus k, minus kx minus k squared, which means that we have 3x minus kx plus 3k minus 2 minus k squared, all that over negative x plus kx plus 2 minus k plus k squared. Now, one thing that was asked from the exercise was to come up with the equation of the horizontal asymptote. And we know, or we should know, that whenever we have a rational function, and let's call it h of x, with coefficient a multiplying x and coefficient c multiplying x in the denominator, so a in the numerator and c in the denominator, the equation of the horizontal asymptote is y equals a over c, the leading coefficients. So if we rewrite this function by finding the coefficients that multiply x in the numerator and denominator, 3 minus k over here and k minus 1 in the denominator, and the other terms, they do not really matter, well, at least not for this step of the exercise, then we know, or we can see, that the equation of the the horizontal asymptote is y equals 3 minus k over k minus 1. So this is the horizontal asymptote. And there you go. In this exercise number 3, we have a question about vectors. Vectors is on topic 3. Now, this is not the most challenging one. There are much more challenging vectors and planes questions in this series. However, this is one that tends to show up every once in a while. Now, let's see how it goes. Consider A and B as unit vectors with angle theta in between them. So we can illustrate these vectors like this. And if these are unit vectors, their magnitude is equal to 1. Now, this is theta as the exercise described. And the way to illustrate a plus b and a minus b, and let's start with a plus b first, is you can copy this vector b and place it over here as a continuation of the path that illustrates the sum of a with b. Therefore, a plus b, it is this vector right here. Now, a minus b works a little bit different. We first need to illustrate what negative b is, what the vector negative b is. And that is b has the same magnitude, which is 1, but a different direction. So it points, instead of pointing up, let's say, over here, we're going to see it pointing down. So in this case, if this vector right here is b, then negative b is this. Now, what is a minus b? Well, that's the same as saying a plus negative b, and that's the reason why we created this vector negative b, so we could view this path a plus negative b. Therefore, a minus b, it is equal to this. You could also illustrate the vector a minus b by placing it over here, meaning like this. Now let's break this exercise into these two cases, a minus b, which again you could draw like this or like this, and a plus b. Remember, these are unit vectors. Therefore, their magnitude is 1. Now let's apply the cosine rule for this first case, which is the easiest case. So the cosine rule states that this side of the triangle over here which is the magnitude of AB, or of A minus B actually, this is equal, when squared, to the magnitude of A squared plus the magnitude of B squared minus 2 magnitude of A, magnitude of B, cosine of the angle in between A and B, in this case, theta. So we have the magnitude of A minus B squared equal to 1 plus 1 minus 2 times 1 times 1 times the cosine of theta. So as a function of theta, we have the magnitude of A minus B equal to the root of 2 minus 2 cosine of theta. Now on to A plus B now. If this is theta, this is theta as well, given that these lines are parallel, and this angle in green, it is pi minus theta. And we're going to use that angle to apply the cosine rule. Do remember, again, that A and B are unit vectors. Therefore, we have the magnitude of A plus B squared equal to the magnitude of A squared plus the magnitude of B squared. Remember, if this is A, then this is A as well. Minus 2 times magnitude of A, magnitude of B, times the cosine of pi minus theta. Now, in this case, we can replace cos of pi minus theta by negative cosine of theta, in order to simplify this identity even more, this equation even more. Now, in order to prove that cosine of pi minus theta is negative cosine of theta, you can use the compound angle identity. So we have this, and given that cosine of pi is -1 and sine of pi is 0, we do get negative cosine of theta. Now, finally, we have the magnitude of A plus B as 2 plus 2 cosine of theta. Now, a question that might seem unrelated at first is, given that the magnitude of A plus B is 5 times the magnitude of A minus B, find sine of theta. Well, we do know that the magnitude of A plus B is the root of 2 plus 2 cosine of theta. And we do know that the magnitude of A minus B is 2 minus 2 cosine of theta. Now, if one is 5 times the other, then we can solve this equation without the calculator by squaring both sides first. So we have on the right hand side 25, careful with this, this is 25, 2 minus 2 cosine of theta. So 50 minus 50 cosine of theta equal to 2 plus 2 cos theta. So 52 cosine of theta equal to 48. So cosine of theta equal to 12 over 13, simplifying these numbers. Now, by using the following trig identity, we can evaluate sine of theta. So sine squared is 1 minus 144 over 169, which is 25 over 169. Therefore, and given that theta is an acute angle, sine of theta is 5 over 13. All right, let's get to exercise number 4, one that involves normal distributions with conditional probability also as one of the last questions. So let's take a look. We have the weights of watermelons being distributed normally with a mean of 12.3 kilograms. And in this case, notice that we were not given the standard deviation. Now, the probability that a watermelon weighs less than 9 kilos is 0.15. In question A, we're asked to write down the probability that a watermelon weighs more than 15.6. And it seems like we're not going to be able to manage that or to do that given that we do not have the standard deviation. Notice the command term, write down. Write down means it shouldn't take any calculation whatsoever for you to determine the answer for this question. And how is that the case? Well, by sketching a bell curve and illustrating the mean over here in the middle, as it should be, of course, as 12.3 kilograms, or let me just write 12.3. One thing that we know is that the probability of finding a watermelon which weighs less than 9 kilograms is 0.15. So let's say that this red line, it represents 9 kilograms, and the probability, meaning the area over here of being less than 9, is 0.15. Now, due to the symmetry of a normal distribution, and noticing that this gap over here is 3.3 kilograms, if we represent that gap to the right now, we should get the same area to the right, which means 0.15. Now, what is 12.3 plus this step of 3.3 to the right, or the addition of 12.3 plus 3.3? Well, that gives us the 15.6 that we were looking for in the first place, or that was mentioned in the first place by the exercise. Therefore, this probability right here is 0.15. Now, how should I write this in an exam? If it's a write down command, you can just state what the probability is. So 0.15 is already enough. Now let's move to the next question. Find the standardized value z for 9 kilograms, meaning the z-score of a standard normal distribution that has the same probability of this 9 kilograms, meaning if you take the probability from negative infinity to this z-score in a normal, standard normal distribution, that probability will be the same as the probability from negative infinity to 9 in this distribution right here. Anything that's a z-score, I'm going to represent in this color purple. So I'm going to drag all of these lines down. I'm actually going to change this color to be a little bit different. There we go. Anything that's in blue, again, represents a standard normal distribution, one with a mean of 0 and a standard deviation of 1, which means that the z-score of this mean, or any mean, it is always equal to 0. Now we need to find this z-score right here, which, as we can see, it's going to be negative. It's to the left of 0. Now we're representing this area 0.15 over here in our standard normal distribution, one that has a mean of 0 and standard deviation of 1. And we need to find this value, which is going to correspond to the z-score that gives us a probability of 0.15 to the left using your GDC. And in this case, I'm using the TI-84 to do it. The area being 0.15, the mean 0, standard deviation 1, and the tail to the left, we get as the z-score negative 1.03643 ... Now, how do we convert the z-score back to our original variable, which is measuring the weight of these watermelons? We use z-score is x minus mean over the standard deviation. We do not have the standard deviation, and by the way, we are already answering B to I, but we will find it through this equation. We know the z-score, we know the x value associated to this z-score, which is 9. We know the mean of this distribution, 12.3, and we need to find the standard deviation. When solving this equation, we get 3.183 ... So B to I, this is done. Now, next part. To be selected to be sold in a local market, a watermelon's weight must be within 1.2 standard deviations from the mean, which means from negative 1.2 standard deviation from the mean to the left, all the way to 1.2 standard deviations from the mean to the right, which means greater than the mean. Now, what is 1.2 standard deviations? This is 1.2 times the value that we got previously, so 3.82. Therefore, 3.82 to the right and 3.82 to the left, given that the center is 12.3, means from 8.48 and 16.1. So we can write it as an interval. 8.48 is less than W, which is less than 16.1. And let me actually change this W to X because we are calling the weights of watermelons X. So there you go. This is the interval. So this is done. Now let's say you select at random a watermelon. What is the probability that it can be sold in a supermarket? Well, that pretty much means finding the area under this curve between 8.48 and 16.1, and we can find that through our GDCs. This is a normal CDF, and we get 0.770 rounded to 3 significant figures. Now we jump to the last question. Of the watermelons on the harvest, 30% of them are seeded ones, and from these, 60% are sold on the local market. Do notice that we're talking about the same watermelons on this harvest. Now, given that a watermelon selected at random is sold in the local market, find the probability that it is a seeded watermelon. Now, you're probably identifying a conditional probability over here, given that was used, these two words, given that, or this expression, and this means that a condition was given, some piece of information was given. We are talking about watermelons that got sold in the local supermarkets. How do we use conditional probability? The probability of A given B is equal to P of A and B over P of B. How do we translate this to this specific exercise? Given that the watermelon is sold in the local market, what is the probability that it's a seeded one? Well, it is the probability that it's a seeded that got sold in the market over the probability that it gets sold in the market. And notice that we have the denominator already from question C to I, which is 0.770. However, when addressing this question, you cannot round just yet. You need to use 0.7698 A3 dot dot dot. And what is the probability that it's seeded and sold? Well, 30% of them are seeded, and from these, 60% are sold. Therefore, the numerator is 0.3 times 0.6. When you divide 0.3 times 0.6 by 0.769 dot dot dot, you get, rounded to 3SF, 0.234. And that's it for this question. Exercise number 5, an optimization problem. We have the following scenario: a curve 2 over x, which crosses this point A. The x-coordinate of this point A is lowercase a, which means, by the way, that the y-coordinate of this point A is y over 2 times the x value, so 2 over a. Given, of course, that the function or the graph of this function crosses this point. In question A, we're asked to find the gradient of the tangent to the curve at this point A. Now, to find the gradient of the tangent of any curve, we use derivatives, which means that we're going to have to calculate dy dx, given that y is 2 over x, or y of x is 2 over x. And by the way, you can rewrite it as 2 times x to the negative 1. And by applying the power rule, we have 2 times the derivative of x to the negative 1, which is negative 1, x to the negative 2. We subtract 1 from the exponent. So dy dx is negative 2 over x squared. At the point A, dy dx is equal to negative 2 over the x value of point A squared, meaning negative 2 over a squared. Now this is it for question I, and now we need to come up with the equation of the tangent at that point, which, by the way, is represented by this red line over here. Knowing that the slope-intercept form of a line is mx plus b, and also knowing that the slope is equal to the derivative at that point, so negative 2 over a squared, we have y equals negative 2 over a squared x plus b. And now we use a point which we know the line crosses, which is point A, which is the point of tangency. We replace the y value of this point over here and the x value over here, so we can calculate the y-intercept, which is b. We can cross out a couple of a's here, so 2 over a equals negative 2 over a plus b, therefore b is equal to 4 over a. Therefore, the equation of the tangent is y equals the slope, negative 2 over a squared x, plus the y-intercept, 4 over a. Now, if we multiply both sides of this equation by a squared, we get exactly, or almost exactly, what we have in the description of the exercise, because we get a squared y equals negative 2x plus 4 times a. So remember, we're multiplying both sides by a squared, which means that we do get a squared y plus 2x equal to 4a. Now, one thing that we already found was the y-coordinate of point Q, which is the y-intercept. It is equal to 4 over a. We found it over here. And to find point R, given that over here the y-coordinate is 0, we can replace y by 0 and use the equation of the line to find x. So we have a squared times 0 plus 2x equals 4a. Therefore, x is equal to 2a. So we have 2a comma 0 as the coordinates of this point R, which means, by the way, that the area of this triangle, which is base times height divided by 2, it is 2a times 4 over a times 1 over 2, which is equal to 4. It's equal to a constant, to an integer. So it is completely independent of a. And what's interesting about that is that it doesn't matter which point A is, the area formed by the tangent at that point and the x and the y coordinates it's always going to be equal to 4. Now we pretty much exhausted all of these exercises, A and B. Now let's jump to question C, in which we need to find the distance between Q and R. Now you can definitely use the distance formula. However, this is just the hypotenuse of a right triangle with base 2a and height 4 over a. So we have d squared equals 2a squared plus 4 over a squared, which, by the way, is equal to 4a squared plus 16 over a squared. And we can factor out a 4. So we have a squared plus 4 over a squared. Now this is d squared. Therefore, d, as a function of a, it is equal to the square root of 4 times a squared plus 4 over a squared. We can move this 4 as a 2 outside of the root. So we have 2 times the root of a squared plus 4 over a squared. And there you have it. Now let's jump to the last question of this exercise, which is to find the value of a, which minimizes this distance. Now, minimizing means that this is a optimization problem. This is an optimization problem. Minimizing is finding the local minimum of this function distance as a function of a. How do we find minimums and maximums? Well, we take the derivative and make it equal to 0. So we need to find where d prime of a is equal to 0. Do know that you could rewrite this as 2 times a squared plus 4 over a squared to the power of half, which is easier to see that we use the power rule followed by the chain rule, which is the derivative of the inside function, a squared plus 4 over a squared. And by the way, the 4 over a squared inside the parentheses can also be written as 4a to the negative 2. So what is d prime of a? It's 2 times the derivative of this, which is 1 over 2. We drop the half. We rewrite the inside function, subtract the exponent by 1, and then multiply by the derivative of the inside function as a function of a. A is our variable now, so keep that in mind. The derivative of the inside function is 2a minus 8a to the negative 3. Remember that over here, we are differentiating the inside function, which is this one. Now let this be equal to 0. We have 2 times half, which is 1, and we have a product between two terms, which is equal to 0. Therefore, either a squared plus 4 over a squared to the power of negative half is equal to 0, or 2a minus 8a to the negative 3 is equal to 0. Now let's solve these separately. Let's square both sides over here, which means that we get a squared plus 4 over a squared to the power of negative 1, which is equal to 0. Now, given that this can be rewritten as a to the 4th plus 4 to the negative 1, which we flip, we find its reciprocal. The denominator is always positive, and when cross multiplied by 0 gives us a squared equals 0, which means that a is equal to 0, which is not possible given that a is a positive number. And now this is the second option. So we have 2a equal to 8a to the negative 3. We can divide both sides by 2, so a equals 4a to the negative 3. And given that the right-hand side can be written as 4 over a cubed, we can cross multiply and get a to the 4th is equal to 4, which means that a is the 4th root of 4, which, by the way, is the same thing as the square root of 2. Now do notice that I never considered the negative version of this value, meaning negative root 2, because we know that a has to be positive. And that's it. Alright, so that's it for week number 6. If you've missed any, you can find all of them in the description of this video. Do share away, share this YouTube video, share the PDFs with your colleagues, and I'll see you on the next one. See you next week.